Hello, all of you. Let us start with Chapter 8, Class 9, Motion, presented by E-Physics class, Fatima Convent High School, myself, Dipali. Now, the word motion is an integral part of our life. You must have come across this word every moment of your life because it is something which we are constantly undergoing. But it's not a simple quantity which can be described in simple words. Let us understand how to describe this motion and various concepts related to motion in this chapter. In our everyday life, we see objects that are at rest and in motion. Birds fly, fish swim, blood flows through our veins and arteries, and cars move. Atoms, molecules, planets, stars, and galaxies are all in motion. We often perceive an object to be in motion when its position changes with time. So, that is what we call motion. The change in position with time is described as motion. However, there are situations where the motion is inferred through indirect evidences. For example, we infer the motion of air by observing the movement of dust and movement of leaves and branches of trees. What causes the phenomena of sunrise, sunset, and changing of seasons? Is it due to the motion of earth? If it is true, why don't we directly perceive the motion of earth? An object may appear to be moving for one person and stationary for some other. For a passenger in a moving bus, the roadside trees appear to be moving backwards. A person standing on a roadside perceives the bus along with the passengers as moving. However, a passenger inside the bus sees his fellow passengers to be at rest. What do these observations indicate? Most motions are complex. Some objects may move in a straight line, others may take a circular path, some may rotate, and others may vibrate. There may be situations involving a combination of these. In this chapter, we shall first learn to describe motion of an object along a straight line. We shall also learn to express such motions through simple equations and graphs. Later, we shall discuss ways of describing circular motion. Let us perform a simple activity 8.1. Discuss whether the wall of your classrooms are at rest or in motion. So you will say, what is there to answer in this question? We all know that the wall of the classroom is at rest, but that is not completely true. We will discuss this in little while. Activity 8.2. Have you ever experienced that train in which you are sitting appears to move while it is at rest? Discuss and share your experience. Think and act. We sometimes are endangered by motion of objects around us, especially if that motion is erratic and uncontrolled, as observed in a flooded river, a hurricane, or a tsunami. On the other hand, controlled motion can be a service to human beings, such as in the generation of hydroelectric power. Do you feel the necessity to study the erratic motion of some objects and learn to control them? Describing motion. We describe the location of an object by specifying a reference point. Let us understand this by an example. Let us assume that a school in a village is 2 kilometers north of a railway station. We have specified that the position of the school with respect to railway station. In this example, the railway station is the reference point according to our convenience. We could have also chosen other reference points according to our convenience. Therefore, to describe position of an object, we need to specify a reference point called the origin. So let us understand what this part tells us. Now we are going to discuss three important points here: motion, origin, and position. Now we understood in the beginning part of the chapter that motion means the change in position of an object with change in time and with reference to any particular position or origin. Now what does this mean? Now if I take this page and I just mark a dot on this page, can you tell me what is the position of this dot? You could give variety of answers to this question. If I name it as point A, and if I have a person standing here, now you will be able to describe the position of this point very easily. If you are this person, you would say the point A is towards your right. Now if there is one more person or a friend of yours standing this side, for this person, point A is towards left. So, in a similar way, position is a reference quantity. You cannot just say a position of an object without giving it a reference, like we saw in the example of a school and the train and the railway station. School is 2 kilometers north of the railway station. What does that mean? That when you move 2 kilometers in north direction of the railway station, then only the school is in that particular direction. But if there is another reference point, the school might be at some other distance or other direction from that position or that point. So we can say that position of an object can be described with reference to any point. Now the point which we refer to for the first time is called as origin. Again, if I take this point, say B, and a road along this point B ends at point C. There is a person or an object who is at point B and walking along this path and reaches point C. Did the position of the object change? Yes, the position of the object changed from B to C. So, the reference point which we started the position of an object is the origin. And the change in position of the object from B to C is called its motion. When the object changed its position from point B to point C, With reference to origin, there is change in position with respect to time, and that is called as motion. So do you understand now? We can describe it with one more example. Now let us take a tree. Near the tree, a person is standing. There are two people sitting in a car. And the car is moving on the road. Now, for this person who is standing near the tree and the tree, the car is moving. And for the person sitting in the car, the tree and the person standing near the tree are also in motion or moving. But what about the person, say, A and B? For person A and person B, they both are at rest. If B will observe A and A will observe B, they both are stationary. They are not moving. And the person C is in motion with reference to A and B. And with reference to C, A and B are also moving. So can we say that motion is a relative quantity? Yes. So in simple words, if we describe motion, then motion is change in position of an object with time and reference to a fixed point or origin is called motion. So, we need a reference point to describe motion. Just ending with this concept, let us take the last example. Say there is a point O, which we call it as origin. With time, you find a person standing at point O, and after some time, say few seconds, you find person moving and shifting to point A, then the object or the body or the person is said to have changed its position with respect to the fixed point origin and is in motion. Now let us go back to the activity and answer that question. Discuss whether the wall of a classroom is at rest or in motion. Now do you understand what does it mean? When you and the wall are standing at a fixed position, you are stationary. Wall isn't moving. But if you see from the moon, the earth is moving and all the objects on the earth are also moving. So, is actually the wall moving or stationary? Both the answers are correct. Why? Because it should have a reference point. So, when I ask you a question that is the wall moving? Your next question should be with reference to what? So, if I say with reference to another wall, then it is not moving, or the person standing in front of the wall, it is not moving. But with reference to the earth or a moving object around it, it is moving. Very simple example you can take is if you are sitting in a car and you are observing the moon, you feel that moon is actually walking along with you. Is it so? Is the moon really walking along with you? Try to answer this question and ask yourself whether this is right or wrong. You will understand what is motion. So, we will understand how to describe motion with a straight path in the next chapter.